Hi and welcome back to a new video. I already mentioned this during the launch video of the 9950X 3D that I wanted to check out this CPU in terms of overclocking potential and also delidding in terms of how much temperature we can improve. Meanwhile, we also offer this CPU as pre-delidded CPU with warranty at Thermal Grizzly, so I definitely know that delidding the CPU is no problem, and I already saw a bunch of these CPU while we did the process. But I so far didn't personally delid the CPU and didn't check what kind of temperature benefit we can expect. That's what we want to check out today. The Seasonic PX 2200 is currently one of the strongest PSUs available, and it comes with two native PCIe 5.1 connectors, which allows to even hook up natively to RTX 5090. That is perfect for any overclocking system or high-end workstations. I'm also currently running this PSU, and so far I'm really satisfied with its quality and performance. The cables are very flexible, there are also cable comms included, and in addition also a 90-degree ATX 24-pin adapter, which also functions as a PSU tester at the same time. The fan is semi-passive, and even at a high load it is still very quiet. Find all information about this PSU in the link in the description. In the first video to this topic we used the 280 ASUS AIO. The temperatures were about 80 to 85 degrees Celsius under high multi-threading load, which was okay. But for better comparison, I today want to just use a normal custom water cooling block with the Mora that is still under my table. I know I still want to finish this Mora project with the Mora that's already mounted on the wall. It's still not fully functional. I just didn't have the time to do that, but we will soon work on that project. But for now, still gonna use the 360 Mora underneath my table. Then we just check normal, like stock condition first with custom water cooling, see how high we can push the CPU, delete the CPU, and then see what kind of benefit we get from direct eye cooling. I will now mount the custom water cooling block onto the CPU. I will use normal thermal paste for that. I would never recommend using liquid metal on the IHS itself, simply because it's not worth the risk. Like if you look at what kind of risk goes with it, the fact that you could have liquid metal going onto unwanted components and also the corrosion that you would have on the IHS, it's simply not worth it. It's only worth it for direct eye. Something I want to add, because I've seen it just too many times, if you apply any kind of high performance thermal paste and because of its viscosity, don't use fast motions like wiping motions like this. Don't do that, because this would look like that. So you see nothing really stuck to the IHS, but using the same thermal paste and just slow movements with pressure from top, it is absolutely no problem to spread. Just take your time, pressure, slow movements, and it will be no issue at all. Everything mounted, we have about 180 liters per hour flow speed through the CPU block. I also quickly want to highlight that we now also have a 90-degree version of the WireView that is a little bit more compact in terms of where the bottom cable connector sits, which makes this incompatible to most of the cards, even this one in the normal orientation. Like if the cable would exit to the bottom, it would not be compatible. But what you can do is you can rotate the display, as you can see in the settings. So you can rotate it by 180 degrees. And with this, especially for vertical mount, this can still be a quite nice solution, especially if you want to monitor the connector temperature. First, we are looking at the stock condition using Cinebench R23 for a heavy multi-threading load. We have two types of CCDs, from 0 to 7 and then from 8 to 15, one with the 3DV cache, one without, and you should see something around 5 GHz under heavy multi-threading load like this scenario. First CCD is doing about 5 GHz, slightly below, and the other one is doing about 4.9 GHz in my condition. The clock is a result of the CPU being heavily power limited, which you can see here, being limited to 200 watts under load, which is also great for the temperature, because if you don't want to do direct eye, if you don't want to modify your CPU, you can see even with heavy multi-threading, you're just seeing like above 60 degrees Celsius under load. So that's definitely great for the stock condition. And this gives us about 42,000 points in R23. It is quite a bit different if we look into a gaming scenario, like in this case Counter-Strike 2, where you can see that the game is fully running only on the first chip, which contains the 3DV cache, and is boosting to about 5.5 GHz. Interestingly, the temperature is not much different. We're seeing close to 60 degrees Celsius under load. The explanation for seeing roughly the same temperature in Cinebench R23, where all the cores are loaded, versus Counter-Strike, where less cores are loaded, is quite simple because you are limited by different factors. In multi-threading load like Cinebench, you are loading all the 16 cores and you are power limited by the 200 watts. In Counter-Strike, you are loading less cores and the CPU can boost higher. But for this higher boost, like higher clock, about 5.5 gigahertz, the CPU needs a higher voltage. And this voltage is then driving up the temperature. So it's expected that you will see roughly the same temperature no matter what kind of application you're running. This also brings the challenge that when you're deciding for what kind of overclock you want to use, that you have to decide on which application you want to focus on. If you want to focus on just multi-threading like Cinebench, then it's pretty simple. You can do a static all-core overclock and you will have good performance in the multi-threading application. But you might lose performance actually in gaming because it might be difficult to match the 5.5 gigahertz across all of the cores, what you would need to match the stock performance in Counter-Strike 2. But the simplest way to start is just unlocking PBO, which we will do right now. This is still the easiest way to get more performance without, worrying about anything, without having to test too much. Just go to PBO, set it to manual, and you can, quick and dirty, just unlock everything. You can definitely tune this better if you spend more time. Like the PPT is just the overall max power draw in watts, while TDC and EDC are current limits. But for this, simple, just try this first. We are rerunning Cinebench R23, where we saw previously just below 5 GHz, we are now seeing just below 5.2. So it's about 200 MHz increase without testing or doing anything else. But we also see a good increase in the temperature, about 81 degrees Celsius now. And also the power increased quite a bit from 200 watts to 270 watts. And we have a performance increase of about 5%. While running Cinebench, I also observed that the CPU core voltage is about 1.2 volt. And I will now fix this to about the same value, do a static overclock, so we will have a comparison value then later on for the delidding. Because this is not supposed to be a detailed overclocking guide for the CPU, I just can recommend that you check out the overclocking guide by SkatterBencher. It's much more detailed and it also points you towards the curve optimizer, which will be typically the better choice if you also want to optimize the CPU for gaming, because it will still give you the higher boost in the gaming scenario and not just a static overclock. This is the max possible with my CPU sample. I have 5.45 on the first CCD and 5.4 on the second CCD. The limiting factor now is the temperature. As you can see, just seconds after starting Cinebench R23, the CPU is approaching 90 degrees Celsius under load. And this also means that it will quickly become more unstable just because of the higher temperature. We also see an increased power draw of 310 watts under load. The voltage itself is similar to what we saw with OpenPPO. It's 1.22 volt under load. And as I said, I just manually increased the clock to 5.45 on CCD 0, and CCD 1 is running 5.4 gigahertz. It's still a masterpiece how much AMD improved the Ryzen 9000 over the Ryzen 7000 when it comes to the temperatures. And we will now delete the CPU. The Ryzen 7000 delidder is still fully compatible with the 9950X 3D. So CPU in the delidder and then putting the slider in, move it back and forth until the IHS comes loose. Now, 15 minutes later, it is loose. If you want to do something like that, you just have to take your time. Don't rush and be patient. You don't have to do it with the drill. It speeds up things a little bit, but just be patient and you have to do it until the IHS really is loose by itself. This could be 100 times, like moving back and forth. Because I just had two cases again, one 9800X 3D and one 9950X 3D, where somebody was not patient enough and then thought, okay, it feels a little bit loose, and then just uses something, I don't know, like a spatula or something to go underneath to apply pressure to move the IHS upwards. And that's like guaranteed killing your CPU. Don't ever do that. Be patient, move it back and forth until it just falls off by itself. Now, just have to clean the CPU. The CPU is fully clean, also applied liquid metal to the CPU and also to the contact surface of the direct die water block. And now we'll remount everything. And now first quick check if everything works without the water cooling attached. And that looks good. And also temperature in BIOS looks great. So I can be sure that everything is working. Contact should be good. Everything else is the same as before. I just reapplied the same BIOS setting. The water flow is about 160 liters per hour and the water temperature is about 24 degrees Celsius, but that is still in idle without any load. This is also a great example to show how inaccurate the temperature reading is, because obviously if we have 24 degrees Celsius water temperature, it doesn't make sense that the CPU is sometimes reading as low as like 19.9 degrees Celsius or 20, 21, 22. This is below the water temperature, which is physically impossible. So the temperature reading is just not as accurate as you might think. Otherwise, this is the same setting as before, 5.45 on the first CCD and 5.4 on the second CCD. Now in R23, we are rechecking the temperature. As I said before, same setting. And we are now hitting about 65 degrees Celsius under load with the same setting. And that's a reduction of over 20 degrees Celsius. The cool thing is also by reducing the temperature by over 20 degrees Celsius, it also drastically decreases the power consumption from 310 to about 290 watts under load. And just for full transparency, again, it's about 1.22 volt under load, so the same as before. The settings I use are also very simple. I just open PBO as I showed before and then set core VID 1.32, then the multiplier for CCX0 and CCX1, and adjusted the load line calibration to level 6. And because we now have more thermal headroom, I'm able to increase the voltage further. I'm increasing by 50 millivolts and I'm setting 5.6 and 5.5. And this is already stable, at least for a couple of runs. 5.6, 5.5. If you have any information how I can get hardware info to update more frequently while R23 is running, please let me know, because this is, I'm not sure why this is doing that. Obviously, updating is set to 500 milliseconds, but whenever there is like a high load, I'm not sure why sometimes hardware info is not updating, but we can still see that peak temperature was 72, which is crazy if you think about that this is 325 watts. But we're running 5.6 and 5.5. Means I have to now check how much more I can push. And without investing too much more additional time, I don't think you can squeeze out a lot more, maybe 25 to 50 megahertz more, but on this chip, it seems to just be above 5.6 on the chip 1 and 5.5 on the second chip. Now also again in the chart, the stock condition of the 9950X 3D in R23 is about 41,900 points. And with the overclocking, we're increasing this to 45,700, which is a performance increase of about 9%. But we're also increasing the power draw to almost 350 watts. That is crazy. In Counter-Strike 2, the average FPS only increased a tiny bit from 602 to 618. However, the low FPS, the 1% lows, increased from 355 to 388, which is definitely not bad. However, power consumption increased from 109 to 161 watts. All of this very similar to the 9800X 3D. That means if you just brute force higher voltage and clock, you will definitely have very bad efficiency. You can get an extra roughly 10% performance, but yeah, at a high price of high power consumption. But there's also an interesting take in just not doing anything. You can still run a direct die, but run the CPU stock, because in stock condition, you will be limited by the 200 watts power draw, but you can definitely increase efficiency by running direct die, because as I showed before, you will decrease the power consumption by up to like 20 watts. That means in stock condition, with direct die, the CPU can just boost higher, and thus means you're increasing efficiency. Now we see, as I said, power draw is limited to 200 watts. We see a temperature of max 51 degrees Celsius under multi-threading load, which is crazy good, 43,000 points. That is an increase of about like 1,000 points over stock. While still having hardware info open, we still lose like 1% or 2%, but you can see the clock is slightly increased over stock by maybe 50 to 75 megahertz. From an objective standpoint, obviously, this doesn't make a lot of sense, especially if you're delidding yourself. You will lose the warranty. There's always a risk involved. And if you go the brute force way of just increasing power consumption or increasing voltage, and with this, the power consumption and the clock, then you get like about 10% extra performance, but a lot higher power draw. That's typically just not worth it. It can be worth it if you go the other way, like undervolting or just stock, and by decreasing the power consumption, getting a higher performance and thus increasing efficiency. That can be interesting. Or then just deep down into curve optimizer and just also try to make your CPU more efficient while getting more performance without significantly increasing the power draw. There's a lot of ways you can tweak this if you want to. I will link down the video from SkatterBencher if you want to check out more details about this CPU and how it can be overclocked. Definitely a great tutorial from them. All right, thanks for tuning in. See you next time. Have a great Sunday. Bye-bye.